Okay, with this color wheel, man has been discussing color since, you know, like he's had eyes basically and so on.
You were born.
Yeah. Yeah, so anyway, there's color theories that go clear back to the Greeks and so on. And scientists did it. Gerald Newton had his color theory and so on. And you know, anyone can come up with a color theory, and consequently, there are millions of them. And one that most of us learned when we were in grade school was what they call the prime color theory. And that's red, yellow, blue. Those are the three primary colors. All right? Doesn't matter what order you put them in, because one's going to be next to the other and so on. So it works out great. That's the prime color theory. That's pretty simple. There's another sort of a variation of that. It's called the Oswald color theory. And they use 6 colors instead of 3. They use red, orange, yellow, green, blue, and purple. Okay, so that works out fairly well. And it's, you know, just a little bit more complicated than the prime. Now this guy Munsell, and there's a little bit up here off of the Wikipedia and so on, that a little bit about his history and so on, and he decided that instead of using 3 primary colors or 6, he's going to use 5. All right, and I think it says in here one of the main reasons is that when you describe colors, it's, you know, you tell somebody, well, as an example, one woman came into Colpar one day when I was there, and she says, I want a fire red. Well, you know, none of the...
What did it do to get fired?
Pardon me?
What did red do to get fired?
Yeah, well, yeah, I don't know.
Work for Donald.
But, yeah, work for Donald. So none of the companies, Testers or Model Masters or, you know, Vallejo, any of them, none of them make a fire red. And she wanted a fire red. So I said, well, they just don't make a fire red. And she said, well, that's what the instructions call for. I need a fire red. So we lined up all of the reds out there in front of her and said, which one looks like a fire to you? You know, and she picked something completely different than what other people would pick. So just by, you know, putting a name on something, it's not a very good way of describing a color. Like for instance, if I say a periwinkle blue, what color is that?
No, but it belongs to the LGBT community.
Yeah, well, yeah, it could be, yeah.
Or bridesmaids.
You're not sure. And like it says in here that Munsell, he referenced Robert Louis Stevenson, one of the greatest writers of all times, of having difficulty describing the color he wanted. And he said there was a topaz yellow, and then there was a red that was neither Turkish, Roman, or Indian. You know, and you know, it's not a very good description. So what Munsell did was he went ahead and he planned this all out very scientifically, like an engineer. Each color was so many degrees from each other and so on and so forth all the way around. And he decided that there were 3 different properties of color. One was hue, which is the color, like red, yellow, green. The other one is value, and that's the lightness or darkness of a color. And the other one is chroma. It's what they have here, sometimes called intensity. And that's the purity of the color, how strong, how intense it is. So those are the 3 values. All right. Now there's other smaller values that you can have also. It doesn't really describe the color so much as well, I guess it does, but you know, there's you can have a flat hue, you can have a semi-gloss or a gloss. So those are all different things that you can used to describe a color. Now, you'll probably take a look at some of the testers' colors and you know, get some of the FS colors and so on in there at Colpar. You want to know which FS color is the right one for an F-16, or you know, or for the new Zumwalt destroyer, something like that. What's the right FS color, and so on. And the FS colors are the federal standard colors. Well, it seems like the federal standard colors have used the Munsell colors as their basis. So next week, Sam is, or not next week, next month, or whenever Sam's here again, he said that he was going to give the Munsell and federal standard colors part. He wanted to go through that, how the numbers relate. But you'll be able to see some of that on here, and so on. On this front page here, you'll see the color wheel, and at the top, at 12 o'clock, is red. Then there's what they call a yellow red, which is a mixture of yellow and red. And there's the yellow, the green yellow, the green, the blue green, the blue purple, and the red purple. Right on back to red again. They all have to be in that order. You can't have them in any other order. In other words, you can't substitute the blue over here for green. It just doesn't work that way. It has to go the way that a rainbow goes. Remember that Roy G. Biv, you know, red, orange, yellow, green, blue, you know, all that goes the same way. And if you can lay it out that way, it's very easy. Now, where you see just a single letter, that's a primary color. Where you see two letters, like yellow, red, that's called a secondary color. And that's by mixing equal parts of red and yellow. All right? Now you can also have tertiary colors, and those are colors that use, well, like 3 or more mixtures. Like, instead of describing it as a yellow red, you might describe it as a yellow red. So that's pretty accurate in the way that you would describe it to somebody if you wanted to describe a certain object. You say it's more yellow than it is orange, or more yellow than it is red. You know, so you have a pretty good idea of which way it's leaning. You know, you wouldn't see something that's a red, yellow, and you know, it's easy to describe that way. Okay. All right, over on the second page.
A quick question on the front then. So when you have a red at the top and a blue-green at the bottom, they're basically opposite of each other.
Yes.
So that blue-green is that then the opposite of red? Is that, in other words, on your color code?
It is the opposite. And you'll find that because there's 5 colors, you'll always have a secondary color opposite of a primary color. It just has to work that way with 5 colors. No other way you can get around it. So if you want to mix some colors and you mix 2 primary colors together, you're not mixing opposites. So you got to do it that way. All right. So if you can visualize like a globe, an apple, anything that's round, a ball like that, and at the top part of the ball it's white, the bottom part of the ball is black. All right, and it goes right down through the core, just like an apple core, and it gets gradually darker as it goes down. All right, that's a value scale. Those are neutrals. They're not any particular color. It's not a yellow, it's not a red, it's not blue. They're just neutrals going right down through the center of this. All right. And then on the outside of this ball, this apple, like where the apple skin is, you're going to see a bright red. And then right next to it, a bright yellow, and then a bright green, you know, going around the outside of this, on the very skin of it. If you took and drilled in to the core, you would see it keeps getting slightly less intense. It's not as bright. So it gets a little bit duller and you know, just not as bright or as intense as I said before. That so that goes all the way through to the inside. That's called the chroma scale. Okay, and that's illustrated on this little diagram up here. Now, you see that he's got numbers on this value scale going up and down the top. As an artist, you'll find that those numbers over there relate to what you'll hear artists talk about. You always hear artists talk about highlights in a painting. Or somebody else will, you know, some photographer will say, look out for the highlights, and so on. And that's a number 9. That's the highest, brightest color that you can get. Then right underneath that is a light. That's number 8. Then there's a low light, number 7. A high medium, which is down closer to the center, but just slightly above. That's a 6. There's a medium, which is average. Then there's a low medium, 4. High dark, which is might be a rubber tire on a car, something like that, where it's in the sun. That might be a high dark. Then there's a dark, and a low dark is the darkest that you can get. That's black in a cave at night. So that's what you have there. And it describes the value scale. And each one has a number. And you'll see that on this scale right below here, you can see these numbers, how they work out with a reddish color. And so on. And then going the other direction, over here, is an intensity scale. And I'm not exactly sure how they measure that and what units that they use. We always used to use 2/3 intensity or 3/4 intensity, half intensity, quarter intensity, something like that. And we never assigned numbers to it. So I don't know what the numbers actually stand for there. Back on page 2, there's a couple of other little definitions in here. You probably won't use them as modelers, but something that you'll hear people talk about is tint, tone, and shade. And somebody might come up and say, oh, geez, that's a nice tint of maroon that you have there, Victor, on your shirt. You know, and that's an incorrect way of using it, because a tint, as you see here, is a color mixed with white. So John would have a nice tint here. All right? You would have a nice tint. John, you would have a nice tint, you know, and so on. The rest of you guys are all blue.
Like, kind of.
Black here, yeah. So, Victor would have a nice shade. That's a color, a hue, and it's mixed with black. So that's, you know, you wouldn't go up to a nice, that's a nice shade of pink. You know, that's an incorrect term there, using it the incorrect way. And tone is where you have a grayed down version. A tone is a color with gray. You probably will never use those as a modeler, but they're good to know.
Because we never use gray on our ships, do
No, we don't. No. Yeah, but you don't, but I don't hear any of you guys saying, oh, that's a nice tone of gray.
I
Either
say it
that-
all the time.
Do you? Nice tone? Okay. Note that, you know, Gerald does that.
Great.
Okay. So, basically what you guys are concerned with, and as modelers, is the scale effect.
Yes.
And that's what you want to get done. But you need to know what how the color wheel works really to get the scale effect. Now, the scale effect, when you're driving down the road and somebody in a red Corvette passes you, you know, and he's right next to you there. It's a very, very bright red Corvette. He gets, you know, 2 or 3 blocks down the way. Is it still as bright? No, and he gets a mile down there, and you can hardly distinguish a red Corvette from a blue or anything. It loses basically all of its color. It gets, you know, that atmospheric effect takes place. So it's less distinguishing. So to get that, you'll see on model warships, Steel Navy, you know, fine scale modeler, all these places like that. All these modelers will advise you, hey, add white to it to get a scale effect. So here you've got this beautiful red Corvette, and you want to make it look like it's, you know, 5 or 6 blocks down the street. You add white to it, and what do you come up with?
Pink.
A nice bright pink, right? And it's not pink, it's a dull red. So what do you do to get a dull color?
Do it afterwards and add a wash to it after it's been painted.
Well, you could, yeah. What
That's
else
what
could
I-
you do?
Well, judging from your color wheel, I guess one of the things that you could do, you're gonna try to change the chromatic principle of the paint itself, right?
Mhm, right.
So that means, I guess you would add, I'm gonna guess, add something that's opposite that on the color wheel itself. So if we're
Right.
going from the outside,
Last paragraph.
Uh-huh.
yeah, okay, there you go. Well, I was
Okay.
just guessing, but